Today, we're gonna continue on and talk about these ratios, but I'm gonna add on. So this is review from yesterday. So let's say you have a right triangle here. And we're gonna call this the angle, not this, don't look at that angle right there.
It's a fishy.
Huh?
On the paper she gave
On the
you?
paper.
Oh, the back of it, just kidding.
This is the adjacent side of that angle, opposite and hypotenuse. The sine, cosine, and tangent are ratios comparing those particular sides. So when you see the word sine, they're asking you, in reference to that angle, the side opposite to the hypotenuse, right? Cosine is adjacent over hypotenuse and tangent is opposite over adjacent. We already talked about those three. Now, there's three more that we need to talk about. The reciprocal of each of those ratios. If you were to flip the sine ratio and say hypotenuse over opposite, if you were to compare the hypotenuse of an angle over the opposite, that's called the cosecant. If you were to flip the cosine one and do hypotenuse over adjacent, that's the secant, and the cotangent is side adjacent over the opposite. So now, you have to know the three reciprocal fractions. When you flip sine, it's cosecant. When you flip cosine, it's secant. And when you flip tangent, it's cotangent. Now, can anyone think of a way that we as a group can remember these three? I can tell you what I see, how I remember them.
For sine, it has an S in the middle, cosine has a C at the end, and then tangent has a T.
That's like
Very good.
There
I get it.
Say it again.
the sine has an S in the middle, the cosine has a C at the end, and then the tangent has a T at the end.
Okay, so you could do that. Now, what I do is, the one that confuses me are these two. The tangent one, yeah, it's the only one with a T in it, cotangent, tangent. How I remember this one is C-O-S, and then these two letters are reversed, S-E-C.
Oh, that makes sense.
So that's can anyone, so you heard Alexa, you heard me, anyone else have a way to remember them? Because you gotta know them.
By
You have to
heart?
know them. Huh?
By heart?
By heart.
my heart, Nick.
There's a
By
lot.
heart.
There are a lot of these
By
equations
heart.
and they all look the same to me.
And you can do it. So now, let's run through this chart right here. What do you see here? What do you see here?
Lots of cosecants and sines, 30s.
What kinds of numbers do you see?
30,
30,
types of triangles?
45, and 60. Right away, when you see 30, 45, and 60, you're going to jump to these two triangles. And I typed them here for you.
Thanks.
Special triangles. 45, 45, 90. 1, 1, root 2. 30, 60, 90. Please remember, the side opposite the 30 is 1. The side opposite the 60 is root 3, and then the hypotenuse is 2. So now let's just run through these ratios. So the first one is the 45er. What is the sine ratio of a 45-degree angle? What's the definition of sine? Opposite over, remember SOHCAHTOA? So it's 1 over root 2. Now, what's the ratio that's the reciprocal of sine?
Cosecant.
It's cosecant. These two are just flipped. So this is root 2 over 1.
Okay, alright. That is actually easier than trying to remember
Yeah.
the other ones.
What?
Like seeing
Same
that.
thing.
I know. I mean like seeing that, just knowing you have to
Oh,
flip
okay.
them is
Okay,
easier
good.
than trying to remember
I'm glad.
which one's which.
Okay, cosine is adjacent over hypotenuse.
Which angle are we finding this for?
Same thing, adjacent over hypotenuse. Adjacent, adjacent, to 45 over hypotenuse. Now, what's the one that you flip is secant. So again, this one's gonna be root 2 over 1. Tangent, here's your 45, 1 over 1. When you flip 1 over 1, what do you get?
1 over 1.
1 over 1.
Yeah.
Okay, let's hop to the 30 angle. There's your 30. So if I asked you what's the sine of 30, what are you gonna say?
1 over 2.
1 over 2. If I say what's the cosecant of 30, what are you gonna say? 2 over 1. Flip it. It's hypotenuse over opposite. Hypotenuse over opposite. How about the cosine of 30? Adjacent over hypotenuse. Whoops. This is root 3 over 2. Let me write that better. Root 3 over 2. Well, what would be the secant? 2 over root 3. Oh my God, I keep writing the 2 over root 3. 2 over root 3. Now, next year when you get to pre-calc, what am I gonna make you do?
Rationalize it.
Yes, okay, so just beware. It
Right.
goes, so it goes deep, it goes a little bit more into it. How about tangent? 1 over root 3, and this one's gonna be root 3 over 1. And then tell me what these are. Sine? Come on,
So don't make that root 3
what
over
is,
2.
what is it?
Root 3 over 2.
2 over root 3. How about cosine? 1/2. 2 over 1. And what's tangent? Root 3 over 1. You guys got this? Okay, now. So, the new stuff was what we just talked about, the sine, cosecant, secant, and cotangent. Yesterday, we did this worksheet. And we only did sine, cosine, and tangent problems. We did them in class together. Now that we know what secant, cosecant, and cotangent means, you should be able to fill in the ones that we didn't do. Which ones didn't we do? We didn't do number 2. So we're gonna do it right now. Number 2. Tell me where 90 degrees is. Draw a little, where's it at?
Right there.
Right there. What's the definition of, let's not talk about secant, let's do the reciprocal one. Cosine. Cosine is x over r. Well, what's the x value right here?
0.
0, and what did we say r was? So now,
1
we
over
don't
0.
have the 0 over 1, we now want
1 over 0.
1 over 0. What's 1 over 0? Undefined. Number 3. Quickly. Where's negative 300 degrees?
At the 60 mark.
Well, if I added 360 to this, I would get a 60 degrees. So let's draw 60.
In the first quadrant.
It's, here's 60. So right away, throw down your ratios. Root 3, 1, 2, quickly, like that. Now, cotangent is what ratio? Instead of saying opposite over adjacent, you're gonna say
Adjacent over opposite.
adjacent over opposite. Do you get it? So cotangent is side adjacent over hypotenuse. So if you want to do the tangent one, root 3 over 1, and then flip it, you can do that. What other one did we skip? Secant. Number 8. 315 degrees is where?
45. Yeah, that's funny, wow.
Where's 315? Here to
Quadrant
here
4.
is 315.
True.
But we're not gonna use that angle, we're gonna use this angle right here, which is in quadrant 4. What is that angle right here? I heard someone say it already.
45 angle.
It's a 45. So this is a 45-degree angle, so can you name these two sides? This is gonna be a 1, what's this?
-1.
Good. Okay, so now, secant
Is cosine.
is cosine. And what's cosine? Adjacent over hypotenuse. So what are you gonna write?
1 over negative root 3. No, no.
Root 2 over 1.
Root 2 over negative root 2.
It'd be hypotenuse over adjacent.
Wait, I have a question.
Yes.
Every time it's like a negative 90, do you just subtract that from the divided?
If it's a negative 90,
Like the next one's like negative 90. Like if there's ever a negative number, you
Fine.
subtract that from 360.
well, negative 90 means go backwards 90 degrees, so it's this, right here. Now, if you want, you could add 360 to it, and it would be a positive 270. So
Because
if
like,
you wanna make it a positive angle, you're gonna add 360 to that.
because on 3 you did that, so I just didn't know.
Yeah, 3, yep. But see, negative 90 degrees, I know it's just going backwards 90.
Okay,
It's
so
just
if it's
easier.
ever like not 90.
Yeah. So what ordered pair is this? 0, -1. Well, tangent, according to our definitions, is the y value over the x value. So what's cotangent? X over y. So what is the x value here?
0 over 1.
What's 0 over -1? 0. What's the next one that we need to do?
Cosecant negative 120.
Cosecant negative 120. So, Sam, I don't like negative 120 degrees. I want to add 360 to this. What do I get? 240. I know where 240 is. It's somewhere between 180 and 270. See, this is it's between 180 and 270. Somewhere in quadrant 3. So I know that my x and my y are both negative. So I just need to know what this angle is right here. So I'm going to take 240, from here to here is 240. I'm going to subtract 180. What do I get? 60. This is a 60-degree angle. So this is going to be negative root 3. So what you have here, you've got a triangle right here. In quadrant 3, this is 60. This is going to be negative root 3. This is going to be negative 1, and that's going to be 2. Did you see? Because you're in quadrant 3. X and y are both negative. Now, what's the definition of cosecant? Cosecant refers to the sine. So instead of saying opposite over hypotenuse, it's hypotenuse over opposite. So this answer is 2 over negative root 3. It'd be hypotenuse over side opposite. Okay, cotangent of 0 degrees. Where's 0 degrees?
1, 0.
Right here, 1, 0. The definition of tangent is y over x. I don't want tangent, I want cotangent. Cotangent is x over y. What is the x value?
Y over
What's 1 over 0?
undefined.
1 over 0 you can't do, it's undefined. You can't have 0 in the denominator of a fraction. What do you think about those? Easy?
When you use
I
x
only
and
wanted
y,
the, X on top.
We're using a graph.
The x is on top.
This is x
Like
over
when it's like a 90 or like a 0.
Or 180.
Yeah, x is 1, y is 0.
1 over 0 is undefined.
Yeah, I gotta remember my chair, right?
I just know what is R mean?
It's from 1.
R is the radius.
Radius.
it's always gonna be 1.
Okay, now, I gave you on the back of that sheet, where we first started off, does everybody have that paper? You have this right here?
Really?
Sorry.
Oh, they're still there.
No, on the back where I just gave you
It's such simplicity.
the back of this one right here. The back of this one. Everyone have this one?
Yeah, that's what you gave us today.
We gave you today. On the back is this. You guys have this? Okay, this is what we're gonna do, a little activity. I'm now going to introduce to you radian measure. But what I wanna do before radians are introduced, I wanna review
Central angles,
degrees.
pizza.
Pizza?
Yeah, like the pizza and ice cream rules where you have like it's in the center and you figure out the angle on the outside. You don't remember that?
I just wanna talk about these angles.
Oh, right.
Now, don't write in the box, right above the box, the angle measure.
Dang it, I wrote it in.
Okay? So can you really quick go around this circle with me in degree measures? So in other words,
0, 360.
0 and 360. What do you do next?
Go up 30.
You wanna go up 30 or do you wanna, you could do 30. You wanna do 30, 60, 90?
Just go around, yeah.
Okay, let's do that. Because you guys are good at this now. 30,
60.
60,
90.
90,
120.
120,
150.
150,
180.
180,
210.
210,
240.
240,
270.
270,
300. 330.
300, 330, and 360. Which ones did I forget?
45.
45.
45, add 45, add 45,
135.
add 45, add 45,
And
add 45, add 45. And you're back to 360. Those are in degrees. Now, there's another unit of measurement that we use, and you're gonna use it a lot in pre-calc next year, and you're gonna use it in science. It's called radian measure. We're gonna use radian measure to measure the angles, the central angles again. Now, I'm gonna tell you, is there something wrong?
I'm just wondering why you had 35 on there, but you were saying add, right?
Oh, it's 315.
Yeah.
Does it look like 35?
Yeah.
Mm,
Oh, not to them.
Yeah,
It does to me.
it's 315.
Just say what I'm doing, 35.
Now, I'm gonna tell you what a circle is 360 degrees, or it's 2 pi radians. That's another unit, 2 pi radians. So I'm gonna teach you how to divide this circle up in radians. So if all the way around, I know it's kind of confusing, because you're saying, too bad it wasn't 1 pi. Like once around 1 pi,
Yeah.
but it's 2 pi. So if you think of fractions, this is how you have to be good at fractions. If you go around once and that's 2 pi, what's going halfway around?
1 pi.
1 pi, good. So can everyone accept that 180 degrees is 1 pi radians?
So half pi is 90.
So what's a half? Yeah, what's a half?
Half pi.
A half a pi.
So 1.5 is 2.
So this is 1.5. You're gonna name this 1.5 as 3 pi over 2.
Oh.
1.5, and then 2 pi is 4, is gonna be 4. So 2 pi, that's 4 pi. 6 pi, 8 pi, 10 pi. Okay, it's going around. 2 pi, 4 pi, 6 pi, 8 pi. So you've got a half, 1, 1.5, 2.
The cherry.
2.5, 3. 3.5, 4. 4.5, 5. 5.5, 6. 6.5, 7. That's going round and round and round and round. Okay, now, what's half of a half? Here's a half. What's a half of a half? These are all quarters now. So we're gonna name this 1/4 pi. So these are all quarters, quarter of a pizza. 1/4. This is 2/4. And 2/4 is 1/2. This is 3/4. This is 4/4. 4/4 is 1/2. 4/4. What's after 4/4? 5/4.
This is 6/4.
This is 6/4, or another name for 6/4
Three
is 3/2. What's after 6/4? 7/4, and that's 8/4. What's another name for 8/4? 2. 8/4 is 2. Okay, so let's do it again. So 0, 1, 2, 3, 4, 5, 6, okay, like that. So 0, this is a half, 1, 1.5, 2. 2.5, 3, 3.5, 4, like that. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. You can keep going. 9/4, 10/4, 11/4, 12/4. You can keep doing that. All right, the ones we left out, how can you break that up?
Thirds.
You could do thirds, or if you think of it as, how many sections do you have? 1, ignore this piece right here. 1, 2, 3, 4, 5, 6.
1/6.
A sixth. So this is 1/6.
5.
This is 2/6. But can you rename 2/6? 1/3. This is 3/6. Can you rename 3/6?
Which one,
1/2.
1/2.
which one should you put? 2/3? Can you, like?
Right here. This is
On the other
Put them
side, do you
both.
put 2/6? Like which
I'm
one do you
putting them
prefer?
both.
2/6?
1/3. You're
I
gonna,
put
you
'em
need,
both.
put them both. Absolutely put them both for now, till you get used to it. So, I'm gonna go back again. 1/6, 2/6, 3/6, what's this one? 4/6, can you rename 4/6? 2/3, that's what I thought you were asking me. 4/6, what's this one? 5/6, what's this one? 6/6, what's this one? 7/6, what's this one? 8/6, or what else could you write?
4/3.
9/6, or you can write 3/2. 10/6, or 5π/3. And 11/6. And 12/6 is back to 2π. So, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. You gotta keep practicing this. You get it? Now, as we work with this, you're gonna start to memorize it. Can anyone tell me an easy way to remember the 45? Pi/4 is the same as 45. You're gonna learn that one, that's the first one you're gonna learn.
If it's at a 4, I'm using that.
Because they both have a 4. Now check out these two goofy ones. 30 is pi/6, but 60 is pi/3. How, too bad a third wasn't 30 and a sixth wasn't 60. It doesn't work that way. So how are you, Alexa? Because you came up with the last way for us to remember it. What do you think?
It's just opposite.
Opposite. I knew you could do it. Opposite. Got it? So 1/6 is the 30 and 1/3 is the 60. You got it? 1/6 pi is 30. 1/3 pi is 60. What is pi equal to? Huh?
I thought
say 1 5.
It's 180.
180 degrees.
Oh.
Everyone,
You want
pi, it is 3.14. Pi is 180 degrees. Now, what are these, what's pi and what's 180? It's just two different, they're both the same angle. It's both 180 degrees, but it's just different languages. So think of Spanish, English. There's different languages within math. One's in radian, one's in degree. So when I say, what is pi radians? You have to be able to convert it to degrees. So if I say, what's pi over 2? You have to know it's 90 degrees. What if I say, what's pi over 3? You've got to know it's 60 degrees. If I say pi over 4, you've got to say 45 degrees. If I say something like 7 pi over 4, you've got to know it's 315 degrees. Now, is there a way that we can do, instead of sitting here and memorizing, but you will memorize it, is there a formula that we can use and use dimensional analysis, in other words, algebra, in order to convert from one form to the other? Just like you convert feet to inches. How can you change, and I want you to look at your notes. I gave you the notes 13.3. Everyone have radian measure? So we talked about this already. How do you convert from radians to degree? Well, what you're going to do is if you're trying to convert to radians, you're going to multiply by pi radians over 180. You don't have to write the word radians, just write pi over 180 degrees. What I do want you guys to do is that bubble. That bubble is very important now. Up till now, I knew that when you wrote 45, I knew it was in degrees. Now, why is it important now that you, because now I'm introducing another type of angle. Now you have to distinguish between if it's a degree or radians. I'll tell you why. Check these out. I can also, not to mess you up or anything, but I can convert this angle. Now the easiest one for me to do for you, and Nick already told us, another way of saying pi radians, I could call this 3.14 radians. So my question to you is, how will you know if you're in radians or degree? You need to put the bubble if it's a degree problem. If there is no bubble, it's considered radians. If pi is in the problem, it's radians. But if you see 3.14, is it 3.14 degrees or 3.14 radians? Because there's a difference. 3.14 radians is 180 degrees. Okay? 1 radian is equal to about 57 degrees, just so you know. 1 radian is about 57 degrees. So now, it's very important, people, that you put in, if it's a degree problem, put that bubble, that little bubble. So now, how do you convert? I'm going to show you right now. Go to the backside, problem number 1. Using dimensional analysis, if I give you a negative 3 pi over 4, now, do you see the bubble there? No, it's radians. I know that that's radians. If I want to convert this to degrees, I want to know, where is negative 3/4 pi? I could take my cheat sheet right here, but we're not going to do it this way. Negative 3/4 pi is right here. It's negative 135 degrees or 225 degrees. How can I get that using algebra? Well, we just talked about that 180 degrees is equal to pi radians. That's, so what you're gonna do is you're gonna multiply this by 180 degrees over pi. Why? Because I want to use dimensional analysis and I want to cross out these pi's. So think of crossing out, getting rid of the pi in the problem. So now, how will I figure out what -3/4 is equal to? How many times does 4 go into 180? You want to reduce this fraction, in other words. You could multiply across, but that's too much work. How do you reduce this fraction? How many times does 4 go into 180?
60?
How many times? 9?
60?
60.
4 goes into 180. 4 times 4 is 16. 45.
Oh,
This is
and
45. Now, what's -3 times 45?
135. Negative.
So this is equal to -135 degrees. Now, what if I wanted a coterminal angle that's between 0 and 360? What would I do with that answer? Add 360, and what do you get?
225.
225. So, that's a good answer, and so is that. How can we go the other way? How can we figure out if we have a 27-degree angle? How do we figure out the radian measure? Well,
Pi
now,
over 180.
we want this bubble on the bottom so we can cross them out, and pi goes on top.
So we're just flipping that as to
Yeah.
what we need?
Yep, yep, you're using dimensional analysis and you wanna get rid of, if there's a bubble there, you're gonna have the bubble in the bottom, 180.
Then you can cross out the bubbles.
Yep, we're crossing out the
If you do
bubbles.
that,
Tell me what number goes into 27 and 180?
you're 3.
9. 3, 2, but 9 is bigger. 9 goes into 27 3 times, 9 goes into 180 20 times. So multiply across 3 pi over 20. And that is automatically in radians. You don't have to write radians, but if you want, you can write radians. Let's practice these next 4. Convert it. If it's in radians, convert it to degrees. If it's in degrees, convert it to radians. So pi over 2, and you guys already know this one probably.
Radians.
Pi over 2 is what, how many degrees? So you want to multiply, you want to do this. 180, so cross these out. How many times does 2 go into 180?
98.
So this is 90 degrees. And we knew that pi over 2 was 90. That's one of the easy ones for us to
So we
remember.
should have a degree by the 180 or no?
Yes, we should have. Yeah. How about 225 degrees? 225 degrees, how many radians is this? So I want it,
Oh, 45 to 36.
No, and then, no, we can take 9 out.
Yeah.
now on your calculator, if you have this one,
Five, four,
want to show you
five.
something?
Yep.
You have 225 divided by 180. So you get that. Hit math, frac, and you get 5/4. You could do that too. So this is 5 pi over 4. 2 radians. You're gonna multiply this by 180 degrees over pi. Yes.
So does the radians count as the pi, or do we just not have a pi?
Hmm?
Do we just not have a pi in this problem to cancel?
Actually, this one, yeah, this one, you're just gonna cross out radians. You're gonna keep pi in it. Actually,
360 degrees over pi.
this one, I don't know if they purposely, because this is something you would do in pre-calc. I don't know if they meant to write 2 pi radians. We're gonna do 2 pi radians. Do 2 pi radians. Because we didn't go through the conversion of getting rid of the pi. Let's do 2 pi radians
Is 360?
times 180 over pi radians. What cancels?
Pi.
Pi radians, what's your answer? That's what I want you to know. Put the pi in there. And then the last one, 150 degrees,
So 2 radians is 360 degrees.
2 pi radians. Put pi in here.
2 pi radians.
We didn't do, there's another way to convert that circle.
Oh, well, yeah, that's on our circle table.
Yeah, that's why. You'll do that in pre-calc next year. You're gonna talk about 2 radians. See, this is, like I said before, this is 3.14 radians. We're not gonna do that. We're not gonna do that. Last one. 150 is what? I know, I ran it out of room too. 150 over 180. You get that? Math? Brack? I got 5/6. Anyone else?
Yep.
5 pi over 6.
Do we have to say radians after that, or?
You don't. When you see pi, it's in radians. You can even abbreviate it RAD. RAD. Questions? Okay, moving along. Now guess what you're gonna have to do? You're gonna have to find the exact value of the sine and cosine of those
Oh, wait.
angles.
Exactly.
Now, exact means, what does exact
You can have
mean?
the pi in the thing, you don't have to like multiply.
No, exact means the 2 special triangles, it's these problems. Actually, let me draw it here. Exact means when we're talking about a 45, 45, 90, I want these exact measures, these ratios. When I'm talking about a 30, 60, 90, this is what you remember, 1, 2, root 3. Now, this is where you have to get good. 30 degrees is pi over 6. 60 degrees is pi over 3. And 45 is pi over 4. Can you
So we
remember
need
that?
this somewhere, huh? So they should be writing this down?
Well, they have it on their circle. They should have it on their circle. Right here, we just talked about that. Pi over 4 was 45, pi over 6 is 30, and pi over 3 is 60. We talked about that,
This is not that
okay? So now, I want to know what's the sine and cosine of, what is that angle?
How many more?
You don't know?
Something 45.
What did we say pi over 4 is? What is pi over 4? How many degrees is pi over 4?
1 over 4.
It's 45. This means this problem is the same, it's the same thing. That means you have to know the equivalent to what a 45 and a pi over 4 is. That's just another way to say 45 degrees in a different language. So now, if it's a 45-degree angle, what triangle, what special
Where's that
triangle am I
45
talking about?
1 root 2.
1, 1, root 2. So what's the cosine of pi over 4?
Just 1 over 1 over 2.
1 over root 2.
Okay, what should I
What's the sine of pi over 4?
1 over root 3.
Opposite over hypotenuse. The cosine of, I'm sorry, not cosine, sine, not to say sine. the sine of pi over 4 is the same as the sine of a 45-degree angle. These mean the same thing. That just means opposite over hypotenuse. And let's do tangent now. Tangent of pi over 4. Tangent is the same as the tangent of a 45er, and that would be what? Opposite over adjacent, 1/1. And here's the picture of it. It's hard to see, but that's a 45-degree angle. And they use these two ratios instead of, I think it's easier to do 1/√2. Okay, now, guess what we have to do?
The sign.
7 pi over 6.
Yeah.
Oh,
210.
This makes me want.
It's 210.
210.
7 pi over 6.
Because it's on the
Where
chart.
is 7/6 pi?
It's 210
I don't want you to say 210.
degrees.
210 degrees.
210 degrees with the bubble.
It's in the third quadrant.
Watch this. 0. Pi over 2.
Oh
Pi.
my god.
3 pi over 2. 1/6. 2/6. 3/6. 4/6.
It's at the 7.
5/6. Don't hate me. 6/6.
Don't hate me.
7/6.
I would throw that
Where's
in there too,
7/6?
That's it, right there.
there.
I stopped right there.
Hey, that's what I
7/6.
said, hey.
So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. So what you have here is this triangle, this 7/6 triangle. Okay?
Okay.
Now,
Alright.
7/6. Did everybody understand that? 1/6, 2/6, 3/6, 4/6, 5/6,
Okay.
6/6, 7/6.
So if it's an improper fraction, you know it's over 180 degrees.
Yes, yes,
Alright.
yes.
Yes. Okay.
7/6. So, what angle is this then gonna be?
10.
210.
This is gonna be pi over 6. In pi over 6, people, we said is a 30-degree angle. Pi over 6 is a 30-degree angle. We did these yesterday. 30 degrees is pi over 6.
Ladies.
So if this is pi over 6, this is gonna be -1, this is gonna be -√3, and this is gonna be 2.
No, it's not.
The only difference is we talked about degrees yesterday, now you're in radians. So you've gotta know that pi over 6, if it's 7/6, this is gonna be pi over 6. Okay? So now, what's the sine ratio, actually, we'll do cosine first. Cosine of 7 pi over 6 is going to be, we're gonna talk about this angle right here. Cosine is adjacent over hypotenuse, so it's gonna be -√3 over 2. And the sine of 7 pi over 6 is gonna be opposite over hypotenuse, so -1 over 2.
Okay, so
And tangent of 7 pi over 6, tangent's gonna be opposite over adjacent. -1 over -√3.
move it down just a little bit.
Yeah, hang on a second. You guys see that? Okay. Now, don't worry about this intercepted arc. We'll do that another day. For homework, this is what you're gonna do. And I'm not gonna be here tomorrow, I have to go to a conference. Let's do one of each, so tomorrow you can work on this in class. Can you read the directions for 6 through 11? I want someone to read them to me.
6 through 11? Oh, hi, 6.
Right?
Each measure
Each
in
measure in
radians.
radian. So what do we do? These are all in degree mode. How do you convert them to radians?
5/3.
Look at this,
You're
track.
gonna multiply by, you gotta figure out which angle you got first, right?
Well, don't worry, they're not necessarily asking you to get it from 0 to 2 pi.
So times pi over 180 degrees.
You can leave it as a negative.
Pi over 180.
So that's what you do on all of these. You're gonna multiply them all by pi over 180. You wanna get rid of the bubble, and you wanna definitely reduce. Now, I don't care if you use your calculator and reduce it, but write it as an improper fraction. That's how you do those 6 problems. Now flip it over. Read the next 6.
Convert it from radians.
You're in radians.
Maybe to measure in degrees.
Now, don't worry about these, actually, put pi,
That's 3
make
pi.
this negative 3 pi radians.
Negative?
Yeah.
Oh,
And, actually don't do 16 or 17. You're gonna do those next year. But I do want you to do negative 3 pi radians. How do you do if it's in radians? What do you multiply these by? 180 degrees over pi. Whoops. What's gonna cancel on these?
times.
Oh, these are up there. 3 pi. So these will cancel like that, and then multiply across. Okay, and then the last 8 problems. I'm gonna add tangent. It only says cosine and sine, I want you to also do tangent. So this is what you do. First of all, where's pi over 6?
Yeah.
You're gonna, believe it or not, you're gonna start to learn, the more you do of these, you'll learn it.
But that's.
What did you say pi over 6 is?
30.
30, so where's a 30-degree angle?
Right there.
Right there.
You got it.
So 1, 2.
Can you name these sides? Yeah,
Couldn't you just substitute like 180 in for pi and then divide by 6 on your calculator?
I mean, you can convert that like we did up here,
Yeah.
if you wanna do that, but it's just more work. You need to get familiar with pi over 6 is 30 degrees. Can you name these sides now? So pi over 6 is 30 degrees. That's what that is. So now, hop into your ratios here. What are these? What's this? Quickly. 1. What's this? 2. What's this? So now, what is the sine ratio of 30 degrees?
Oh, opposite.
So sine of pi over 6 is the same as the sine of 30, which is 1/2. What's the cosine of pi over 6? Root 3 over 2. And what's the tangent of 30?
1 over root 3.
Yeah, and that's what you're doing on these.
Square root of 3.
Wait, what, are we getting a different worksheet for tomorrow?
Nope, this is what you're gonna work on tomorrow. I may have add something to tomorrow because this is not enough.
I think it
I think
is.
it's enough.
I
You should
really
actually
do.
try to make it do it.
So we're not doing.
I like it.
BC Yorkshire. Oh, what are we doing today?